Hey guys, I'm live now. Can anyone confirm if audio, video, etc. looks great before we get started? And do let me know how many problems were you guys able to solve? Like I was able to solve six problems, so I will discuss all the six problems. And the order would be A, B, C, D, E, F, E, I believe. That works fine. And yeah, do make sure to subscribe the channel. C1 was a bit confusing for me. Yeah, actually it is. Do let me know how many problems were you guys able to solve, and if there are any audio video let me know if audio is fine, etc. before we get started. Looks like most of the folks are between one or two problem and three or four, not more than two. What is the rating for D? I'll probably rate it around 1800 to 2000, somewhere between them. You can probably look at the number of aces, and that would be a good enough proxy. And after some time, the rating of the problems would be available here, so you can just check here as well. So this is loading the rating over here, then you can find the problems rating over here once this forward parsing is complete. Actually, I would kind of a bit disagree. I found C to be easier than D. So this is where we are. While the F was definitely harder than D, but I found actually C to be easier than D. So that's where we are. So let's just wait for a couple of more minutes and then we will get started discussing all the problems. So this is where we are. And yeah, actually my favorite problem in this set was E. Like it had one of the technique that I haven't used it in the contest so far. And this was the first time that when I have used it. So this is where we are. So let's get started now. First problem says you define a Euclid algorithm sequence of length k for two positive integers x greater than equal to y. This is a bit important concern that x is more than equal to y as the following sequence of positive integers. A1, A2 up to AK, where A1 is X, A2 is Y, and for any I, the equality AI plus 2 is equal to AI mod AI plus 1 holds. For example, if the sequence is X equal to 13, Y equal to 8, and K equal to 4, the corresponding Euclid sequence becomes, first we have 13 and 8, then we take 8 mod 13, which would be 5. Then we take 5 mod 8, which would be 3. And this is how the sequence gets created. You are given a sequence B1 up to Bn. You need to determine whether it is possible to permute its elements so that it becomes a Euclid algorithm sequence for some positive integers x greater than equal to 1. So this is where we are. Overall, the problem statement is like this. Mhm. So it says we have a sequence. Like for example, we have a sequence where we have some x and y given to us. We say that a1 equal to x, a2 equal to y, and then a3, a4, a5, so on. Every next number, is taken by taking mod of these two numbers. So for example, a5 is a3 mod a4, and so on. And it gives us a sequence B. It says, can we reorder these elements so that like the sequence becomes Euclid sequence, so that new sequences yeah, like Geeky Ansu says, my idea was remainder will always be decreasing, then why not go from large to small? Actually, that's the great idea. For example, if we look at, if we say that AI plus 2 is equal to AI mod AI plus 1, then this remainder would be less than AI, right? Like whenever we have A mod B equal to C, then the remainder C is always less than B. So this implies AI plus 1 is more than AI plus 2, and so on. So overall, if we continuously take mod, like our original sequence would be like this: A1, A2, which would be more than A3, which would be more than A4, which would be more than A5, which would be more than A6, and so on. And we are also given that A1 is X, A2 is Y, and the problem statement also says the X is greater than equal to Y. So this means like the overall sequence is a decreasing sequence. Decreasing sequence. And we also know that X would be the largest number and Y would be second largest. So we can find the largest and second largest number. We can change X to the largest, Y to second largest, and then create n digit sequence. And then check if that is all the elements in the new sequence are same as the original sequence. Any questions, anyone on the idea? Like the overall idea is like, because we are taking mod repeatedly, the mod will always be the less than the number with which we are taking mod with. So this gives an idea that among A2 to AN would always be a decreasing sequence. And the problem also says that X is greater than equal to Y. So this means like A1 would be the largest number and A2 would be the second largest number, and so on. And once we have found X and Y, what we can do is we can generate the sequence, and then we can see like whether all the numbers we have found are the numbers that were present in A or not. And that would be the overall idea we have on this problem. Any questions, anyone? So like now if we have to jump into the code for this as well. Yeah, like I also did not pay the attention that X is greater than equal to 1. And that's the reason why I have one WA on here. So the idea can be like we can sort A and we can find the largest and second largest number. So we can generate the sequence. Now if A is equal to B, like essentially I can just check if the set of A and B are same or not. So if A equal to B, I have found my X and Y. Else I should print minus 1. And this is problem A, everyone. Any questions, anyone? Like the crux of the idea is like X and Y are always unique. Yeah. So this is the problem statement we have. Okay, I kept getting runtime error. Don't know why. 1 second. So like basically you make potentially get runtime error based on what language you are using. And for example, consider this case. 551. If this is the sequence, then the B that would be generated would actually have zeros. And you may try to do a modular division by 0, and that would be the reason for the runtime error. Like in C++, this did not give us a runtime error, but definitely the other languages can give you. So you need to be a bit careful. Like that, to be honest, this would be actually the foolproof idea we have already. put all the numbers initially equal to -1, and that's where we are. So this can be the reason, like you need to careful about not taking modulo with 0, and you may get runtime error based on it. Like for example, so like actually I just found like my solution was in context wrong. For example, if I would have done 5550, and if I am not careful about this being 0, then I can actually print incorrectly. So you need to be a bit careful about this test case as well. So overall, this is where we are. Any questions, anyone on the problem in? I believe I may not be able to submit it yet. Yeah, system testing has not started yet. So I am, yeah. Yeah, BI is better. Okay, you are right. So, right, that was an important constraint. So, this is actually an invalid test case. So, good catch. So, any questions, anyone on problem A? Then we will jump on to problem B. Yeah, like we can also sort in decreasing order and then check. Yeah, like actually that was my in contest submission. But here the goal was to make it simpler. So if there are no questions from anyone, then we will jump on to problem B. So let's jump on to problem B then. This contest was on easier side, like at least I would say I found it easier because I was able to solve the problems, but definitely may not be the case with everyone. Problem B says palindrome 12 and 2 terms. It says you are given a positive integer n. A pair of non-negative integers a and b is called beautiful if the following condition holds true. A plus b is equal to n. Number a is a palindrome. Number b is divisible by 12. Now we need to find beautiful pair or report that it does not exist. A number is called palindrome if and only if it remains same when its digits are written in reverse order. For example, 1, 2, 3, 2, 1. If you reverse it, it will again be 1, 2, 3, 2, 1. 6, 7, 7, 6, 5, 0 are palindromes, while number 1, 2. So I believe in my first contest as well, I was able to solve only one problem. So that's fine. So the problem statement is a bit short. Wait 1 second. Why is it jumping to the first one? Wait 1 second. 1 second. One second. One second. Let me see what's happening with my pen. Hmm. Okay, looks fine for now. So, like, the idea is we are given a number n. Whether if you can read the app, then please do so. Like, I'm not sure if I understood your problem, but yeah, like we have to find two. We are given a number n. We have to find two number such that a is greater than equal to 0, b is greater than equal to 0, a plus b is n, a number is a palindrome, and b number is divisible by 12. Now, what can we do over here? Like, the crux of the idea is like, let's try to first brute force it. Then how can we do it? We can take b to be the largest number. Like, first, so we can brute force it this way. We can start with a equal to 0, 1 up to whatever n we want. And every time we check if the given equation is satisfied or not. So, and this will actually get an AC. Like, that's the most simplest thing we can do, right? We can start from a equal to 0 up to n. Whenever we find a pair, we print it. If we did not find a pair going up to n, then we are done. So, like, that's the smallest thing you can do, and like that will actually get an AC over here. The crux of the problem would be figuring out why this will get an AC, but that would be the next piece. No, this will actually not give you the TLE, like that's the crux. If it's palindrome, then we can print. Like, we have to print -1 when we have not found, right? We can convert number x to string. And I claim that this will be an AC solution. Like why it works would be the interesting idea. Like on high level, it looks like n is up to 10 to the power 18 and everything. So this should get a TLE, right? So like my claim is like we will be all, since we are breaking out whenever we have found a pair, and we will, like, the crux of the idea is we will find one pair, like a less than equal to 24, we will always find one pair. Or our n would be, so this is where we are. We will either find pair with n and like, or yeah, like that's where we are. Like you don't even need to go up to n more than equal to 2. Like now, like the question is how. This is also fine. So the idea is like, since we know that b is a multiple of 2, multiple of 12, then what would be like the possibilities of a? Let's first say r is the remainder when we divide n divided by 12. Then possibility for a is a equal to r, a equal to r plus 12, a equal to r plus 24, and so on. Right? Any questions so far? Okay, what I am saying is, since b is a multiple of 12, and we know that a plus b is equal to n. If we take mod for 12 on both the sides, we will get a mod 12 is equal to n mod 12. So we can first take r equal to n mod 12, and then we can start with checking a equal to r. Like a would be of something like this. A would be equal to r, r plus 12, r plus 24, or something like this. Now, what are the possible values of r over here? R would be somewhere between 0 up to 11, right? And the key idea is like 0 is a palindrome, 1 is a palindrome, 2 is a palindrome, 3 up to 9 is a palindrome. 10 is not a palindrome, 11 is again a palindrome. So if this remainder is not equal to 10, then we can just print a equal to r and b equal to n minus r. So like in most of the cases, the number you will find one value pair between 0 and 11 only. When we have r equal to 10, the next possible choice we have is again 22. And the idea is like 22 is also a palindrome. And this is where we are. So if what I would say is, if our remainder is not equal to 10, then just we can just print r and n minus r. This would be a, this would be b. And if remainder equal to 10, we can try to print r plus 12, which would be 22, which is a palindrome, and n minus 22. And like only we also have a constraint that a should be less than equal to n. So like when remainder is equal to 10 and n is less than equal to 22, then we have to print minus 1. And like this is the overall idea over here. So this was the in context submission. Let's first find the remainder mod 12. If remainder is not 10, then we can directly print r and n minus r. This remainder would either be between 0 to 9, all of them are palindrome, or 11, 11 is also a palindrome. And if the number is greater than or equal to 22, then we can print r plus 12 and n minus r minus 12. In this case, r is 10 only. So this number would be 22 and this number would be n minus 22. And otherwise, we print minus 1. So any questions, anyone? Like the overall idea is like you have to do a bit of casework, and like in the problems like this, it's always helpful. In problems like this, it's always helpful to try to analyze small cases, and that's how you can try to solve this problem. Any questions, anyone? So like n is 118, but the idea is like even a brute force, if you cannot figure out how to solve it, you can get an AC, because what we have established is like we will always find a solution when either a is less than or equal to 24, or like the n itself was less than 24. So you will you can print -1, like you have analyzed all the possibilities, and this is where we are. So any questions, anyone, on problem B? So like the system testing is still running on, otherwise I would have tried to submit the solutions, and that's where we are. If there are no questions, then we will move on to problem C. Like do let me know like if there are any questions, or feel free to react with something if you believe like you are done, like there are no questions, so that I can move on to the next problem. So this was our problem B. Like the key takeaway from my side over here is like always try to do some casework, and doing some casework on it, you would have realized that you have to try to take a is as small as possible, and then you will figure out that a equal to 10 does not work, but you will realize that a equal to 22 works, and then we are done. So this was our problem B. And if there are no more questions, then let's move on to problem C then. Vessel's heights and the two versions. Easy version. Like the primary difference between C and the problem F is like in problem F, the numbers are up to 2 into 10 to the power 5. And in problem C, like the numbers are up to 3000 only. The problem statement is like this. There are n communicating vessels of infinite height arranged in a circle. Circle is quite important. The base area of each vessel is 1 centimeter square. And between the ith vessel and the I mod n plus 1 the vessel, like between each two consecutive vessels, there is a connection of negligible volume at height hi centimeter. For each vessel I, find the maximum total volume of water in centimeter cube that can be placed in these vessels under the condition that ith vessel remains empty. Formally, you are given an array h1 up to hn, a cyclic array of non-zero, non-negative integers w1 to wn is called good if the following holds true. For each I from 1 to n, if max of hi and the next is more than hi, then both of them should be equal. In other words, if the maximum of two neighboring elements of the array W exceeds the corresponding element of the array H, then these two neighboring elements of the array W must be equal. For each I from 1 to n, output the maximum possible sum of W1 to Wn among all the good arrays under the condition that Wi is equal to 0. Any questions, anyone on the problem statement? Were you guys able to understand what the problem statement is asking us to do? Or do you want me to spend some time on the problem statement itself before we jump on to the next problem? Before we jump on to the solutions? Like it has tried to prove a bit formally over here, but I'm not sure if it's that intuitive. Statement is clear, unable to understand, a bit confusing if alternative definition were not given, and so on. So overall, like the crux of this problem is something like this. Let's assume that we have n wells with us. Well 1, well 2, well 3, well 4, well 5, well 6, well 7, well 8. Like we have wells placed in a circle. And now each of the consecutive wells are connected by a small pipe. And this pipe is at different heights. So I'm trying to show the problem statement in a different way. What I'm saying is like, let's forget about what is asked in the question. I will give you one alternative representation of the statement. What I'm saying is you are given n different wells and each of the wells are connected with a pipe, and like these pipes are at some different height from the ground. Now what happens when you add water into these wells? So for example, if you have a long well like this, let's say there is a pipe connecting over here of height at height 4. There is a pipe that's connected at height 5, and then these two wells are connected at height 3. Like I am saying, like for example, we have two different wells they are connected nearby. There is a pipe between these two at height 3. There is one more pipe that's at height 5 which connects well like this, and there is also one more well that's connected at height 5. What happens when you add the first 1 liter over here? This part will completely fill that 1 liter, right? Then let's say you add one more. The idea is you just keep adding water over here. Then when you add 1 more liter, the water would look like this. And when you add 1 more liter of water, this water would look like this. Now when you add 1 more liter of water, it will come over here. But because you have a pipe of height 3, all of this water will shift over here. And you will end up creating 1 liter of water. And this 1 liter by now when you add 1 more liter of water, what happens over here? It gets added over here first. And then this water will move from pipe on this side. Now when you add 1 more liter of water, what happens over here? It first got added over here. And then due to this pipe, this water gets moved over here. So far you have added 6 liters of water. Now what happens when you add 1 more liter of water over here? This first gets added over here, and half of the water moves on the right side. Now this is half, this is half. Now when you add 1 more liter of water, what happens over here? First 1 liter gets over here, and after some time, half of this water will move on right side, and so on, right? Like this is how, if you have two wells connected with each other, how the water among them will fill, right? Any questions on how the water gets filled between these two pipes looks like? Any questions, anyone here? Like this is how two wells connected at a height 3, the water will be filled among them, right? Now our problem statement is same. It says we are given a circle which is of wells connected here. It says, for example, let's say we want to keep this well empty. What is the maximum amount of water we can fill in all the remaining wells? And essentially, that's the problem statement for us. Like, if we want to height well empty, what is the maximum total water we can fill in all the remaining wells? What is the maximum amount of total water we can fill in the remaining wells? Like, this is what our problem statement is. Any questions, anyone on this? I can try to explain the problem statement again, and then we will jump onto the solution. Actually, I think F is we are required some stack to do order n instead of n square. I actually ended up doing a DP, and that's where we are. Can the vessel overflow? Like, the pipe is the tallest one. Like vessel, we can assume that the vessel height is infinite. So vessel does not overflows. Vessel height is infinite. Just that two vessels can be connected at some height. So the movement, whenever the total water in one of them crosses it, it will move to the other side unless they become equal. So vessel height we can assume to be infinite. And the crux of the idea is like, whenever, even if the vessel height is infinite, just because all the wells are connected, after some point of time, all the wells must have water, then only you would be able to add more water. And if you have to keep one particular well empty, then you won't be able to add infinite water. So this is where we are with respect to the problem statement. Any questions, anyone? Like on what exactly the problem is asking us to do? Then we will jump on to how to solve this problem. Like, I mean, the well we want to keep zero, the pipes are at infinite, then we can keep water above the pipe in the other side. I'm not sure if I understood your part, but if, like if pipes are infinite, then overall the water can be at infinite, but pipes are not at the infinite distance. Like they have some specific height which is between 10 to the power 9 or something. If two wells have infinite height pipe, then they are never connected. So you can keep whatever we can there. So this is our problem statement. And like there are possibly many ways to solve this problem. The way I solved this problem kind of made a bit easier for me to even solve the F problem, but that's where like we have two different versions. Overall, the idea is like since n is up to 3000, we can do something n square for the problem C. I tried greedy on it but failed at some test cases. Yeah, like overall, the idea is greedy only. So, like, my idea was as follows. Like, let's say we are solving for the ith pipe, ith well. Or let's say we first try to solve for 0th well only. Then what we can do is we can place length and let's try to first make the circle as a straight line by opening at a place where we have nth pipe. Yeah, like you are right. If the pipes at the one we want to keep dry on both the sides are very high, then others, even if they are relatively high, we can have water above the pipe. Because what I'm saying is like the height of the well is infinite, just that there is a pipe at some height. So after some point, water can flow between the wells if they are not equal. Let's say we are solving for the ith pipe. Then we can first create wells like this. Let's say AIth well is over here. All of these are connected at some height. And so on. Let's say this is our AIth pipe. This is AI plus 1 up to somewhere we have A1 and the A1 up to AI minus 1 again starts over here. Now my overall idea is like let's try to fill wells from one or the other side. Let's first look at these two wells. Let's say this is at height 5. This is at height 3. Let's say this is at height 7. 4, 9, 8, 9, and so on. Now my overall idea is like what we can greedily try to do is we can look at the two wells that are connected to ith well. On this side, you have pipe at height 3, and on this side, you have pipe of height 5. So, what I am claiming is like if I fill water up to height 3 over here, then this will not overflow to the right side. The key reason for this is on other side, the pipe is at height 5. So, like water from this side will flow only if all of these have water more than 5. Does this claim sounds true? Okay, like let's say if I have pipes like this is the next pipe over here. This well is at height 3, this well is at height 5. Then I can very safely fill water up to height 3 over here. Like it doesn't really matter ki like even if this is at height 2, then also like I can very safely fill water up to height 3 over here. Like some part will can move on right side, but I am saying is like at the end state, like as long as this part has water up to height 3, then it will not move to this to the original well. Like does this claim sounds true? Or any questions over here? Like the key reason why I am claiming this is like because on this side the water is at height 5. So even if we have low, high, whatever the connection over here is, as long as water is up to 3 over here, all of these can also have water up to 3, and this the pipe at here is 5. So this is where we are. Then I have filled, let's say, water at height 3 over here. Like this is actually greedy. Like 2 pass, not, I would say 2 pointer greedy if I have to put it this way. Now what I am claiming is like, now let's say, for now let's fill water in each of the wells and then we will see how it's moving or something like that. Now let's say we have filled water up to height 3 over here, and for now let's forget that the water can move around. Yeah, like this is true only at the lower side. Definitely we cannot claim that we can fill water up to 5, height 5, and we are done. No. I have looked at the smaller of 2 and 5 and 3, and I, for the smaller one, I have claimed that if I fill water up to 3, then it will not overflow to the other side. I cannot definitely claim that if I fill water up to height 5 over here, then it will not flame. There would be cases when it can move out. So only compare the smallest of 3 and 5, and that's where we are. Now, let's say I will fill water of height 3 on this side, and let's move our pointer a bit right side. Now let's move over here. Now again, what would be the maximum water I can fill over here so it will not flow? Even though we have a pipe at 2 over here, we have a pipe at 3 over here. So I am claiming that if I fill water up to height 3 here, then also it will not overflow to the right side. Because here I have filled up to 3, here also I can fill up to 3. If I fill less, then these two can equalize and do water they want, but water will not move to the right side. This is with the constraint that on right side we have what pipe at 5, height 5. Does this also claim sounds true? Like it doesn't really matter. Yeah, like overall, like the solution would be n square, and that's where we are. So if I have water at height 3 over here, even if I have pipe 2, what all I have to look at is or another way to look at it is like this. For each pipe, let's look at all the parts on right side and find the maximum height of pipe. And look at all the pipes on the right side and find maximum height. Let's say the maximum height you can find on all the right side is 12, and maximum height we can find on all the left side is 10. Then overall the claim is like we can fill water up to height 10 over here and it will never overflow. Like if we have to put it this way. If I am focused on this pipe, if let's say we have water pipe at 2, we have pipe at 3, we have pipe at 5, we have pipe at 4, we have pipe at 7, we have pipe at 6. Then the maximum on right hand side I can find is this 7. And the maximum on right side I can find is this pipe at height 5. So as long as I fill this water in this pipe up to height 5, then it will not overflow to the one over here. Because the idea is like if you fill 5 up to 5 here, like this will get 5. If due to this 4, this can also get water up to height 5. But this is definitely not reaching the right side, and this is definitely not reaching the right side. And this is where we are. So like the overall idea is like, let's focus on a particular well. Let's figure out what is, yeah, like if let's say we have well at height 5 over here and well at height 6, then we can actually fill water up to height 6 over here. Then maximum on this side is 6, maximum on this side is 7. So we would be actually able to fill water up to height 6 as well. And like this is my claim, like in an equilibrium, this is how you can find the maximum height for all of the wells. Like the idea is like if we want AI to be empty, then we have this well AI. AJ would be somewhere over here. Find the maximum height on this side of the circle. Find the maximum height on this side of the circle. And take minimum of these to maximum height. That's the water you can fill without breaching. It's the maximum water that can be filled in AJ. In AJ. And this is where we are. Any questions, anyone on this problem first? What I am claiming is like you want to keep a particular well empty. Then to figure out how much water you can keep in a well, you go through like both the sides of the water. And this is where we are. This is a bit hard to implement. Like you can actually implement it in order n. No, like what I am saying is like you need to look at the maximum height among all the wells. If you are focused on this well, this is your AJ. Then you have more wells over here. And this is your AI, a well over here. Like this is connected over here, this is connected over here, this is connected on this well, this is connected on this well, this is connected on this well, this is connected over here. Then look at the maximum. This is the maximum on this side, and this is the maximum on this side. So overall water you would be able to fill it would be this much. Like if desirable is 6, its pipe is at 5, then water will come out as well, right? You are technically right. What I am saying right now is like, for example, this is at height 5, and this is at height 6, and this is height at 9. Then the key idea is like here I would be filling water 6. Here also I would be filling water 6. So in the end, the math will add up. Okay. At first, if you fill water 6 over here, then it will definitely overflow some part over here. But the idea is like you fill water 6 here, you fill water 6 here. And irrespective of some water moves left and right, doesn't really matter. At the end of the day, both of them will have 6 water. So this is where we are. Like even if there is a well at height, if you initially add 6 over here, it will move out. So this is your AI. Like this will definitely be empty if you fill water up to 6, because like that's the maximum height you can find on the left side is 6, maximum height you can find on the right side is 9. So taking minimum of these two would be the maximum. If you, as long as you pour water up to 6 height, it will never go out. So like the overall idea is like, first let's forget that water can move among each of them. Let's fill water in each of the wells. And what I am claiming is like, at last I would be filling water in such a way that it will never flow out. So rather than initially worrying about how much water it will go over everywhere, what I am saying is, in this case, let's fill water up to 6 height here. Water up to 6 height here. Let's say this is at 3. Water up to height 3 here. Here also like water up to 6. And like let's say this is 4. Water up to 4 over here. Let's say I first fill water in everything and then I will let it flow. What I'm claiming is like, the way I have filled water here, water will not even move to one or the other cell. 3 is the minimum of both of the side, and like that's how it is. Initially, if you just fill water 6 into here, because the well is at height 5, some part will move here. But the idea is like, let's first decide how much water we will pour into each of the cell, each of the well. And what I'm trying to do is like, I am filling in the sufficient amount of water. Even if there is a mix match, at last the water will remain 6. Like, can you see why? Like, if I pour 6 here, 6 here, 6 here, 4 here, 3 here, then water will definitely not move to anything else. Like, these two have pipes at a smaller height, but if I have poured water 6, 6, 6 in all of these, then water is definitely not going to move into something else. So like, our AI is over here, like this is for 3 and this is for 4. Like, Ritik, can you probably give me a test case where you believe water can move out and I can try to convince your idea? Like, the idea is, even if this pipe is at 3, if this pipe is at 6, then if I fill water up to 6 over here, then this pipe at 3 doesn't make much difference, because water is not going to move from 6 to 3. If this is my air, if I have a pipe at height 3 here, if I have a pipe at height 6 here, and so on. So as long as I fill water up to height 6 here, this pipe will ensure that water does not move from this side. So this height at 3 doesn't really changes anything for us. So that's why this AI would be empty. Like, from this side, if I am filling water up to 6, then water cannot flow into this 5. So it will not even flow, like this particular water will not flow this side. So even it cannot move further here. And same goes for the other side as well. That's why I am taking minimum of both of the sides. Like, we don't have to fill AI. That's the crux of the problem. Okay, we have problem 3, and we need to dry run it for A0, right? Like, if we can fill water in A0 as well, then we can actually keep infinite water as well. So let's take the example 3, where we have 3, 4, 2, 6, 1, 5. And we want to keep A0 empty. A5. Let me just draw A0 again here. These two are the same wells. These two are the same wells actually. Then we have water at height 3 here, pipe at height 3, pipe at height 4, pipe at height 2, pipe at height 6, pipe at height 1, pipe at height 5. We need to keep this and this empty, both of them are filled. Now what I am saying is, for this pipe, let's see what is the maximum height we can get on the left side, which is 3. And what is the maximum height we can get on right side, which would be 6. And minimum of 3 and 6 is 3. So let's fill water up to height 3 here. For this, what is the height from this side to reach this well? This is at height 4. And on right side, this is at height 6. So I can try to fill water up to height 4 here. Let's forget about this 2 here. Now let's look at this well. What is the height on the left side, which is maximum height on the left side is this 4. Maximum on the right side is this 6. So let's fill water up to 4 here. And this also works because now this 2 height doesn't really make sense because both of these have same height. Now let's look at this one. What is the maximum on the left side, which is this well at height 4? What is the maximum on right side? Wait, no. Here we have height 6. So for this, the maximum on this side is 6. And the maximum on this side is this 5. So let's try to fill water up to height 5 here. Now let's focus on this side. What is the maximum that is available on this side, which would be 6, and on this side is 5. So let's try to fill water up to 5 here. And overall water we have filled over here is 3 here, 4 here, 4 here, 5 here, and 5 here. And now like we have a pipe of height 1, but both of these are same water. So like no more water will move here. We have pipe at height 2, but both of these have same water. So it's not moving anywhere. And I am claiming this is the most optimal way to fill water here. So this is where we are. And like this is also the optimal answer for this part. Overall 5 plus 5, 4, 21 is here. And 21 is the most optimal value here. Any questions, anyone? For every first we are finding, like since the all the wells are in a circle, there are two paths using which one particular well can be connected to the other one, either going from the left side or going from the right side. So we try to find what is the maximum height on both of the sides a pipe exists, and then take minimum of that maximum, and we are done. So this is where we are. Any questions, anyone on the idea first? Then we will jump on to like how to implement this idea. So this is where we are. And we can directly, how do you prove this taking minimum of maximum is optimal? Like this is actually the upper bound you can have an answer for. Like, like, is it fair to say that whatever I get over here, I cannot have an answer more than this? Because what I am trying to do is I am trying to fill water in each of the wells in such a way that they do not even go to the other side itself. Like my idea is like, let's say like we have first blocked all of these pipes, filled water in each of them, and then we will open these pipes so that water can transfer if something is not in equilibrium initially. If I look at, because like the idea is same, right? First you put water in each of the well. Either the water can move around even when you are filling in the water, or you can say ki, like first I have blocked all the pipes, I have filled in water in each of the wells, and then I have opened the pipe so that if there is a need to go for an equilibrium, water can move around. Like this will actually, if I put it this way, then if I have an AJ here, and if I have AI here, and then I have some set of wells from this side and some set of wells from this side. If the maximum here is 5 and if the maximum here is 10, then as long as, if assuming that I already pulled in the equilibrium water in each of them, like as long as I have put water 5 here, then this 5 will not cross whatever well we have at 5. And overall, like if you try to analyze the structure of the problem which we will get, like this problem will actually also give us the equilibrium as well. For example, if I have something at 5 here and the maximum here is 10, but if this is connecting at 2, then my same idea is actually also giving me water 5 in both of these scenarios. First, what I am trying to prove is all the water that I have filled in each of the cell, even if I add 1 more liter of water in any of the cells, then that will definitely overflow to AI. Is that part easier to analyze for? Because I have tried to put in the maximum water I can in each of the cells. I am not claiming that, let's say, if I put water 5 here, for now, let's assume that even 5 can overflow. But if I put water 6 here, then that will definitely overflow. Does that looks a bit easier? Okay, like water we have got from each of these values, that's the upper bound for our answer. Okay, if you add 1 more liter using all the values we have found like this, then that will definitely go to AI. So like now we have an upper bound of an answer and we have to find maximum. If we can prove that this upper bound is in equilibrium, then we are done, right? Okay, first I try to find for each of the cells what is the value I can possibly put in so that it does not go through AI. And my idea was like for each cell, try to put water in such a way that it does not go to the any other well. And if you can put water like this, then you are possibly done. So the way I tried to do was like I first kept all the pipes closed. I added water in each of the cells, and then I'm opening the pipe. But what I'm trying to do is I will put water in such a way that it's in equilibrium. So like this gives us an upper bound for an answer. And now you can possibly try to analyze like the cells will move always into the pair, whatever the maximum you got left hand side, whatever maximum you got right hand side. All the places between them would actually be smaller, and you would end up putting in the same water everywhere. So like the crux of the analyzing for this is if you find the answer this way, the water is definitely not going to move into any other cell. And that will actually prove that you can actually put in all the waters you have over here And that's where, yeah. So optimal would be like first trying to prove that we cannot have water more than what we have found by this algorithm. And then analyzing that this structure actually gives us the water that will not even flow to the sideways at themselves, leave alone moving to air. Now I have I. We want to keep IDX empty. Now let's go over or go n times to the right side. Water in IDs. I'm doing one pass to the right side, and then I will do one pass to the left side. And then since we have to keep, like, essentially two parts. One, you take a well, move n times to the right side. Then you start from the same well, move n times to the left side. And then since the water in a particular cell needs to be empty, you put there. And this will actually give you 1 second. Mhm. I need to take one more to the left side. 1 second. Mhm. Ith height contains ith height connects I and I plus one. So this looks okay to me. Like actually, I implemented a slightly different algorithm in the context. So this is where we are. Like that is also same but slightly different. Now I'm missing off by one somewhere over here. Mhm. Yeah, like let's just take a black and board. Yeah, A4 here. if I had to look at 5, then the fourth pipe connected this. H4 connects this. H5 connects this. If I take one step forward, then this is where we are. Here H3 will connect these two. So wait one second. Let's put it this way. So if I take J steps, pipe would be IDX plus L minus 1 model, because first time you would be at I5. Well, would you at IDX plus L. You take max of the pipe height and you put max at the well. Now I again go from whenever I'm going left side, this would be my well, and this would be my pipe as well. Yeah. So off by 1 is something that you need to take a look at it, but that's very relevant. This would be problem C. Any questions, anyone? I'm also submitting all of my earlier codes. So you can refer them later if you want. This is the idea where we look at it based on reminder. Yeah, like how to do it in order n. I actually my solution was probably NlogN or something, I don't know, but I will jump on to when I move to problem F. So next I will move to problem D for now, like solving problems in the increasing order. So this is order n square solution. Like if you directly want to read it, you can just open my solution for F and go and look at it. Now I will possibly, because I am discussing problems in the increasing order, now I will discuss D, E, and then move to F. Or D, F, and E. That makes more sense. So any questions, anyone on problem C? If not, then I will move to problem D. This is order n square. We have to now possibly solve it order n or log n when we move to problem F. So I will first discuss problem D and then I will move to problem F. Any questions, anyone? Now looking back, I believe like the original comment where someone said ki, like they found problem D to be easier than C. I kind of agree to it if you are trying to prove the solution, and that's where you are. Any questions, anyone on problem C before we move on to problem D now? Let me know with some reacts or something so that I can move on to the next problem. Okay. Now let's move on to problem B then. It says you are given an integer k. There is a sequence of n bit binary numbers a1 up to a2 to the power k plus 1, where a1 and a2 to the power k plus 1 are given to you and others are unknown. Then the unknown numbers are filled in as follows for the over k steps. Suppose that before the k step, the number with the indexes p1 up to pm are already filled in. Then for each j equal to 1 to m minus 1, you look at the midpoint of each of the cell and fill it with the XOR of the two numbers at the endpoint. These assignments happen simultaneously. After that, all the numbers become filled. And after some point of time, all the numbers would definitely be filled. It can be shown that the process will always fill all the numbers completely. This is what the process looks like for k equal to 2 and n equal to 3. Initially, we have a1 and a5. First, we fill a3, which would be XOR of these two numbers. Then we have 1, 3, and 5 filled in. Then we fill a2 and a4 with the XOR of the respective numbers. Now we need to compute this expression, which is x1, y1, x2, something like that. Essentially, for each of the numbers, we have to count number of ones and number of zeros, multiply both of them, and find the sum for all the numbers. So this is where we are given multiple test cases, t up to 10 to the power 4, n and k. The given numbers are actually n-bit number, not something you can put it in an integer. So you have to even read this somehow in a string. So like the problem statement is a bit clumsy, but overall, like this is something like this. Like first your number, let's say k is equal to 4. Then a1 and a17 is given to you. You find the midpoint of a1 and a17. That would actually be a9. You fill in a9, which would be the XOR of a1 and a17. Now you have a1, a9, and a17 with us. You again find the midpoint of both of these corresponding pairs. A1 and a9 midpoint would actually be a5, and a9 and a17 midpoint would actually be a13. You fill in these two. A5 would be XOR of a1, a9, and essentially the idea is you have some set of numbers filled. For each consecutive pairs, you fill it, find the midpoint of that, and you fill it with the XOR of numbers on these two ends. Now you have a5, 9, 13, 17 filled in. Now you look at midpoint of a5 and 3. Here you will get a3. Here you will get a7. Here you will get a11. Here you will get a15. Now you fill in these with the corresponding XOR on the numbers on both the sides. And in the last step, you will actually have a2 here, a4 here, a6 here for these two, a8 here, a10 here, a12 here, a14 here, and a16 here. Each of them would be the XOR of the numbers on both the sides, and now your complete array is filled in. Like, can you see how the numbers are getting filled in over here? And now we have to count number of ones and zeros in each of the numbers. Xi is number of zeros in I. Yi is number of 1 in AI. And we simply multiply these two and take this sum for all the numbers. Any questions, anyone on the problem statement? Like this is what problem statement is asking us to do. How do we solve it would be a bit differently. I am not yet going into the solutions, but any questions anyone on the problem statement? And then like people in the chat just gives me some hands up or something on the problem statement. Now let's try to solve this problem. Now the idea over here is, if I look at the particular segment, I have these two numbers somewhere between, let's say with me. Let's say first I look at A1 and A17. Now, how does the middle element looks like? If both the sides have 0, then the middle element becomes 0. If this side has 1, this side has 0, then this element becomes 1. If this side has 0, this side has 1, then this element becomes 1. If here we have 1, here we have 1, then this becomes 1. Like my idea is like probably let's look at it the other way. Like let's say we have A1 here, A17 here, and A9 here. If I have a 0 here, then this number also be the bit here, like I have the bits here. If I have 1 on this particular bit and 0 on this particular bit, the bit for this AN9 becomes 1. If I have 0 here and 1 on this bit, then this bit becomes 1. And if ith bit over here is 1, ith bit over here is 1, then this bit becomes 0. Like I'm looking at the bits, these individual bits. And since at the end of the day, we have to just count number of ones and 0 in each of the numbers, does the order of how bits are arranged, does it really matters? Or if we can somehow know how many 0 0 pairs exist, how many 1 0 pairs exist, how many 0 1 pairs exist, how much 1 1 pairs exist. Based on this pair count, I can also figure out the pair count for all the numbers here. If I know the count, then I can also find count of A9, right? Because at the end of the day, I don't have to find A9 and then count bits for it. I can directly try to find count over here. So like this would actually be our idea. We will maintain K, like how many numbers we have to fill in, and what are the combination of 0 0 1 0 0 1 and 1 1 on both the sides, and then try to fill in the middlemost number and then run it again. Now with this, if I know the count of 0 0 1 1 bit for A1 and A17, using that I can also find A9. Like my main idea is like, since if I know that ith bit of A1 is 0, ith bit of A17 is 1, then I can find that ith bit of A9 is 1, which would do the XOR of these two. And since I have to only count number of zeros and number of ones, Number of 0 and 1, not the original numbers, not the original numbers, not the numbers. So as long as I know how many bits have 0, 0 on both sides, you know, if I know how many bits count of with 0, 0 on both sides, count of bits with 0, 1 on both sides, count of bits with 1, 0 on both sides, count of bits 1, 1 on both sides, then using this I can also find how many zeros and how many ones will exist for A9. I can find number of zeros and number of ones for A9. Does this sounds correct? I am yet to go for recursively how I will find A5 and A13. So now we can actually do the same thing. Why in pairs? Like we, because like if I give you say, let's say A1 has 3 zeros and 4 ones, A17 has 1 zeros and 6 ones. Using this information, you cannot figure out how many zeros and ones will exist for A9. This is not at all useful information for us. But if I know that 2 bits have 0, 0, 1 bit have 0, 1, 3 bits have 1, 0, and 1 bit have 1, 1, then I know that taking XOR of these two will give me a XOR. Taking these two will give me a XOR of 1. Taking these two will give me a XOR of 1. Taking these two will give me a XOR of 0. So the number of zeros would be 2 and 1. And the number of ones would be 1 and 3. That's why I'm going into the pairs. Because I need to know the precise value for each of the numbers. Now I have A1 over here, A17 over here, A9 over here as well. Using this same information again, I can also find how many 0, 0s will exist, how many 0, 1s will exist, how many 1, 1s will exist, and how many 1, 0s will exist. So I can again go recursive for A5, and on this side I can again go recursive for A9. Sorry, this time it would be A13. And like this is the whole idea. You keep going recursively and just add DP at the top of this. Like we don't really need to know whether it's A9, A17, A6. All we need to know is how many different numbers exist between them. Here we have 8 numbers. Here also we have 8 numbers. A5 and A17 are same pair. Interesting claim. Good idea. Like I did not observe it, but that makes a bit life a bit simpler as well. So like the claim here is like we have A1 here, we have A17 here, then we have A9. A9 is actually XOR of A1 plus A17. Now I would have A5 here and A13 here. A5 would be XOR of A9 plus A1. And if I put the value of over here, then this will become A17. A9 is again A1 plus XOR A9 plus XOR A1. This becomes, this is sorry, A17. If I put A9 from here to here, then this will actually become A17. Similarly, my A13 will be again A9 XOR A17. A9 is XOR of A1 XOR A17 XOR A17. This again becomes A1. So, like, actually a pretty neat observation. I was doing a DP there, but let's say you have A1, A17, and this is A1 XOR A17, which is your element. Then you again end up here. This number would actually become A17. This number would actually become A1. So this is actually the same problem. This would be A5, just that the length is decreased by 5. This is also the same problem, just that the length is decreased by A5. And here also these, you can try to recursively solve this, but this actually gives us a neat idea that all the we would only have 3 different types of numbers in the complete array. Like, this is actually an interesting observation. I was doing DP, but check series, 3 different numbers in the complete array. In the complete array. So this is one observation you can try to, now you can count zeros, how many times each number appears, try to find zeros, ones, and everything. That's one way to do this problem. The way I will do is I will continue my DP idea where I know like how many 0, 0, 1, 1, 0, 0 pairs exist, and all I need to know is like the difference of the numbers in each of them. You can also use that observation and try to do this. First, I am counting number of 0, 0, 1, 1, 0, etc. pair using a one array of length 4. You can possibly use the 2D matrix as well. Then look at the first and last number. How many 0, how many ones exist? Or you can possibly put it in a map. That's even more easier. Now I have this map. And this the difference of the numbers. I also have a DP. Mm, hmm. Like I will just keep it start with K. Left bit is z dot x dot x. Right bit is z dot x dot y. And the count is z dot y. If both the bits are same, then 0 in this number increases by 1, else the 1 increases by 1. Like let's say current bit, which is left bit, right bit. Let me put it this way. And then I also maintain a similar map. Left half, like, and right half. Left half, left bit plus current bit. This pair increases. For the right half, current bit and right bit increases. Current result is 0 for the current number. Let's add it. And let's recursively run it for left half. Find the sum of all the numbers in the left half. Find the sum of for all the numbers in the right half. Return current result. Now what we are doing over here is this map is already computed. Return that map. And run this recursively only if this 2 and 4 is from. Now we need to also count for zeros and ones. Huh. If f is 1, f1 plus plus, and f0. Like f is for the first number, and L is for the last number. LLI. First count for the first number. then count for the last number, and then run it for all the numbers. And that's where we are. So the overall idea was my DP state was actually like I have two endpoints. I know how many numbers are between them and how many bits have combination of 0, 0, 0, 1, 1, 0, and 1, 1. Yeah, this is problem D. And since I know that both the endpoints, how many bits have 0, 0, 1, 1, 0, 1, 0, 2, using that I can also find how many, what is the middlemost number. Now I look at left half as the middlemost number and the left element, right half as the middlemost number and the right element. I try to figure out again how many bits are 0, 0, 1, 1, and so on. One second. Hold on a second. Okay, this should be a bit too clumsy, but okay, here I have to multiply by. One second. Mhm. Yeah. So, like, let me probably open the whiteboard again. So, my overall idea was like, once I know how many bits have 0, 0, 1, 0, and on the both the ends, my middlemost element will also look like this. 0, 0 will give me 0, 0, 1 will give me 1, 1, 0 will give me 1, 1, 1 will give me 1. Now, based on the same count, I also can recursively solve for A1 up to A9. Because 0, 0 gave me 0, so I can know how many times 0, 0 will appear here. Because 0, 1 gave me 1, know how many times 0 will appear when I try to solve for this part. 1, 0 will gave me 1, so based on it, I can figure out how many times 1, 1 will come up here. And 1, 0 will give me 0, so here it again gave me 0. So again, I have the same perfect information for how many times each pair exists on both of these endpoints. And I can solve for this part. Similarly, I can look at A9 and A17 and I can figure out the same part. All I need to know is how many numbers I have to fill in between. I I care less about the index 1, 9, and 17. All I need to care about is how many more numbers are, how many remaining numbers to fill between these two sides. That's all I need. I don't really, I care less about the original indexes of the two numbers. If I know how many numbers I have to fill in between, then I can also figure out, I can keep filling in the numbers inside it. So like the idea is like treating whether this 9 and 17 exist or the index is 1 or 9. Since the algorithm is same, all the numbers will end up being same. So that's what I am keeping track of. I have these two numbers. This is the set of the endpoints, and how many numbers I have to fill in between. That's all I care about, and that's what I am passing it as my DP state. I don't really know what is the exact index of the left endpoint, right endpoint, because like the array that gets filled in between will always remain same irrespective of what side I'm filling in. So that why I am keeping a track of k over here. So this is how I actually coded in the contest. One neat observation was like we have only three different types of numbers in the array. So you can also keep a count of each of those numbers and try to solve for that as well. That would be another way to solve this problem. So we can keep a track of how many times S exists, how many times T exists, how many times XOR of S and T exist. And you will return three different numbers as the response, and you can try to take those XORs and everything, and that would be it. So like you have when you have A and B on the end, the middlemost element is XOR of A and B. Now when you try to solve for A on one side and XOR of A on B on the other side, the middlemost element will again come out to be B. When you have A XOR B on one side and B on the other side, the next element would come out to be A, and you can keep trying to solve the same problem again. So that would be another way to solve for this problem. Any questions, anyone, on the problem D? Next, I will probably move to problem F because that was the most easiest problem in the contest, and then I will go to problem E, and then we would be done with this one. Like, let me know if there are any questions on problem D. I will take 2 minutes break since it's been 2 hours since we started. So, and then I will jump back. Let me know if there are any questions from the first four problems so far. So this is where we are. So like the code is definitely not simple. Like feel I can probably write a better code for this problem, but for the sake of just let's move forward. Any questions, anyone so far? If not, then we will move to problem F and then problem E. If anyone is looking for the rating, these are actually the rating of different problems. Okay, let's move on to problem F then. So I will not repeat the solution of problem C, what we have already established. Like let's try, we have already solved this problem in order n square while discussing C. You can rewind back if you want to look at the solution. We will simply start from the same idea. Like you remember initially we were looking at the minimum heights, maximum heights on both the sides and taking minimum of them, right? Let's try to solve that same problem again, but we would still first keep it in order n squared so far, but a different way to code for it rather than the earlier code we have written. Now my idea is like let's try to iterate in an increasing order. We have these values with us. Again, same set of values. Rather than going over a two pass idea that we did for the last time, what I'm trying to do is I will try to move it in an increasing order. Let's say I have 3 here, I have 5 here, I have 2 here, I have 6 here, I have 4 here, and I have 2 here. So first I will compare these two pipes and look at which one is the minimum. The minimum is 3. So I will fill water of height 3 here, and it's a 2-pointer. Initially my pointers were here. I will fill water of length 3 here, and then I will move my pointer here and here. Here the height is 2, but the maximum, we keep maintaining the maximum so far. So maximum of 2 and 3 would again be 3. And here we have 5 on one side. So this time we will fill water of height 5 here, height 3 here again. And let's move our pointer a bit further. The maximum seen so far here is 3, maximum seen so far here is 5. Now we have got a 6 here. So the maximum on right side would be 6 actually. And the maximum on left side is 5. So let's just fill 5 here. What I am saying is like the maximum will, like I am trying to look at which side now I have got a minimum so far and running over here. And next I will do is I will move my pointer from here to this side. Like I will first suggest you to probably rewind back and look at my solution for C. I am continuing from C again. I will probably won't repeat the solution for C again. The idea is like the stream is already a bit long and you can move back and come back on this problem. So like the observations we have already on C, I am skipping here. So now we have filled water of 5 here and we move our pointers a bit further. Then the maximum on right side is again 6. The maximum with this 2, the maximum on right side is again 5. Now, since this 5 is smaller, I will fill water of height up to 5 here. And then I will march forward my pointers a bit. The maximum from this side would be 5, maximum from this side would be 6. So I will fill water of up to 5 here, and that's how I would be done. Overall, the idea is like initially we were looking at the maximum. Okay, so if you were here, then I can probably jump in. Like our initial observation was for each well, we have to see what is the maximum height we have on left side, what is the maximum height we have on right side. And then we were taking minimum of these and taking it sum for everything, right? Once we have decided what the empty cell is. Rather than doing it this way, I am iterating on the same algorithm. Rather, I look at both the endpoints. I see which endpoint has a minimum. I put that minimum there and I move that endpoint a bit further. So if I have this 3, 2, 6, 2, 5, I first look at these two numbers and let's say like A0 is here for now. Let's say we are solving for H. 0th value is here. If the minimum on this side is 3, then I can safely conclude that for this well, the minimum endpoint is 3 only. And move our 2 pointers like this. Now look at what was the minimum for this well, because the for this 3, if you see, on this side you have 5. So whatever you get from this side would at least be 5, but whatever you got from this side is actually 3. If I have this A0 as the empty well, this A1, and let's say this is my whatever is. If I have well at height 5 here and well at height 3 here, then for this, because of this 5, whatever you can get would actually be more over here. On this side, you can get more than 5 or 5 because you already have 5 here. And on this side, you got just 3. So I am claiming that we can directly fill in 3 over here. We don't have to really find the maximum in this whole segment altogether. So at each step, I am trying to fill water on one of the endpoints. And when I go to 2 here, here I again had water at 2. And on this side, I have 5. So what I am maintaining is the maximum on from the left side so far, minimum maximum on the right side so far. And which of them is minimum? I fill that water here and I move a bit further. So again, I can fill water of height 3 here and I can move on to the next one. Now this time we have water at 6 here. So the maximum we can get from the right side would actually be 6. So instead of filling here, I fill water here. Because here we have seen 6, here we have seen 5. So my claim is the minimum for this well would actually be 5, because irrespective of what is exists in between, this endpoint is 6, this endpoint is 5. So on this side, whatever you have at a bare minimum, you will get 6. So fill 5 here and move to the well on the next side. And so on. So the again, like the 2-pass algorithm same, but I just compare whatever I have seen so far, and based on the 2 wells, I decide which one would actually be the minimum. So I haven't actually filled the remaining part here as well. Like you will possibly have to keep running the same algorithm. The crux of the idea was, if I look at this well, if I have 3 on this side, I have 5 on this side, then I know that from right side I will definitely get at least 5. And since this side had only 3, so this well will have 3, and I know this. So I just fill in 3 and I move to the next. Now I got 2 here. So for this well, I know that from the left side, maximum I can get is maximum of this 2 and 3, which was 3. And this side 5 already exists. So there is no point in actually figuring out the maximum on this side, because the minimum of these two maximum would actually be 3. Now when I got to 6, then I know that okay, for this particular well, the maximum from right side would be 6. So for for everything over here, the maximum from right side would be 6. I would put it this way. So once I encounter 6, for everything, all of these wells on this side, the maximum from left side would at least be greater than equal to 6. But we know that for this well, minimum right side is 5. So I fill 5 here and I move a bit further. Like if I have to put a word for it, minimum using 2 pointers. Like this type of DP idea has definitely appeared earlier as well. And like overall, this is the solution for this is again n square, but this is one way to code the same thing. I will I will code the same thing for problem C again. Like this is again n square, but like this idea will actually give me now my left max. And move left index a bit further. And this is another way to solve problems. Any questions, anyone? Or something that I should explain again? Now, essentially, what I have solved is like this is again n square, but now I am doing it in a 2 pointer way. And all we had to do was optimize this a bit further to solve the overall problem. So now all I did was to, like, the same two pointer idea. All I did was to optimize it a bit further, and then we were done. Like the idea, one idea was like first, whenever you have to solve for cyclic array, one thing we can do is like we can append the same array to it again. And then rather than going for this mod and all stuff, we can simply forget about this mod. Like this is a bit needless. Like you can try to see why it works, but that's where you are. And rather than doing this iteration for all the numbers, I can run it this way. This is still order n square, but any claims or questions anyone on this implementation so far? Now the crux is we have to use a stack to optimize this over here. Like first I can put DP like this. Overall, the idea is like instead of taking maximum again and again, we just run it rather than keep taking maximum. We just keep running left endpoint until we find a new left maximum. Like Y Combinator is a bit fancy way to write recursive algorithms. You can actually read my blog over here. What is Y Combinator? For now, let's just say it's some fancy ways to write recursive functions. And once we are done with this, we just run the same algorithm again. And if we had already covered full segment, we just return 0. One second, looks like I'm missing out on something. Oh, one second. Mhm. I'm possibly counting 0 again. This should be less than 1 second. This is fine. Okay, looks like I'm missing one of the index. I have index 1, I have index 2, but index 3 is not anywhere, right? Okay, I'm debugging a bit. Oh, I need index 3 only. First, I have 2, 3. Okay, something somewhere is not right, and I'm still trying to figure. Left max should be 1, right, instead of 2. Yeah, at this point of time, I'm explaining less, but coding a bit more. But like that's all we needed for it. So like this is actually the two-pointer implementation of the same idea. Rather than keeping a track of maximum, once you have the left endpoint, just jump all the points such that the current point is more than the indexes so far. I have found some left max and I have found some right max. What I'm saying is I will keep 2 pointers. Both of them would be the respective local maximas. I compare both of them, which one is smaller. Whatever was smaller, I just continue running it as long as the next set of points are smaller than this. So if I have to look at this, if I have 3 here, I had 5 on that side, then I can directly skip 2 as well because the maximum here would again be 3. And like you can also see when I was running this algorithm, that was also the case. Once I have found 3 here, keep running until you have all the elements less than equal to 3. So skip 2, fill 3 there, skip so on. Once you will land up with 6 again, you will have 5 on this side. We had 2 again. So this time we have 5 here. So now from this 5, keep running until you find elements less than equal to 5. So you will fill 5 here, you will fill 5 here, you will reach here. This would be 5 again, and you keep doing it. Like this is slight optimization on my previous part, but still it's order n square. And the crux of this problem is we can now optimize these for loops using a stack. Like what we need is what is the next index which is more than left on the, if I keep incrementing this on the left side. And here what is needed is what is the element which is more than my current element before it. So I will probably not go into the details, but you have something known as monotonic stack, using which you can find these 2 pointers first. Among the current set of elements, the index before it, which is more than the current element, you can do it using step. And for the current index, what is the element, first index where you will find element more than the current element on the right side as well. Like now the new code is exactly same as this, where I have these 2 left endpoints. DP state is these 2 endpoints. If we have already computed these 2 pair of indexes, directly return them. Otherwise, my left max, my right max, if left max is smaller than equal to this, I find how many times my that while loop will run. That is simply how many, where I have the max index. I keep minimum with right because I don't want to jump outside the boundary. I directly add my left max and I then solve for right up to this. if my right endpoint was smaller, how many times I can move from right until I find some element that is more than the current element, and cap your run algorithm with L directly at that sum. Now recursively solve for left up to that part, and you keep returning it. That was actually problem enough. Like, since it's problem F, I would also expect you to probably try to derive these algorithms again, the parts again, why this works, but this is where we are. Any questions, anyone on problem F? Or just react some thumbs up or something, and then we will move on to problem E, and that would be the last problem for today. Any questions, anyone on problem E? Like, I have kind of walked you through a lot of code for F compared to C, because most of the essential ideas I already discussed while I was discussing C. So this is where we are. Any questions, anyone? The last problem we have is problem E. Like, bro, how are you so smart? I won't say I am smart, but I would just say that I have been practicing all of these problems for quite a long time. Like, I created Codeforces account 8 years ago, and my first contest was in 2018 or something like that, March 2018. And right now we have June 2006, 26 or something. But like, this is all the practice that I have done so far, and this is where we are. And actually, like, problem E is my favorite in the complete set. Like, because like I have used a trick here, like that was the first time I have used possibly in the contest. I have seen this trick couple of times earlier as well, probably 4 or 5 years ago, but that's where my problem is. One more interesting part is like why this works, why this does not get a TLE, like because left endpoint is up to n, right endpoint is up to n. Why this is not order n square? So I will mostly leave it as an exercise for you. Like, I will have a simple claim. For each left, there would be only possibly two right endpoints that you have to bother about. Like, if you are at a left index, look at the maximum up to right. Either that is when you will start incrementing left, or look at the second maximum on right side. Either that would be the point when you will start incrementing the left endpoint. Similarly, for a particular right, you look at the maximum on left side. Either you will reach that point, then you will have to keep decrementing right, or look at the second maximum. Once you reach there, you will keep decrementing the right endpoint. Maximum or second maximum would be based on which point we want to keep empty for. So overall, my claim is like the number of DP states here should not be more than order of n. Total upper bound possibly 4n or something like that. Like, this is a hand wavy proof, but this is where we are. And since we have used DP of map, log n can come from map or something, and that's where we are. So like the time complexity here is order n if you don't count log n due to this DP check. So that was problem F. And yeah, like the intuitions for this max, possibly not sure, but yeah. Problem E technically is also something similar as well. You again have two pointers. You try to do something for this and the same DP state. Even for problem E, the DP state is same. You have left endpoint, right endpoint. Just that you don't keep DP there. So this is where we are. Problem E would be the last problem for us. And that's where we are. Vlad, Misha, and two arrays are problem. Vlad, Misha, and the two arrays. Vlad thought of permutation B of length n. After that, for each I from 1 to n, he counted the number of pairs L to R and the minimum value among PL to R is equal to PI and wrote this number into AI. Now he gave Misha numbers A1 up to AN and asked him to guess the permutation P. However, Misha quickly realized that it is not always possible to uniquely restore the permutation P. Therefore, he decided to surprise Vlad and tell him the number of possible permutation P of modulo n. Help him with this. Note that Vlad could have made a mistake and there are no such permutations possible. Like a long problem statement. TLDR is like this. Let's say we first start with the permutation P. Permutation means all the numbers are unique from 1 to n. So for example, if I take permutation, if this is my set, I count how many sub-arrays of this permutation has minimum element equal to 2. And which if you count, you will find out that there would be 3 arrays over here where the minimum element is 2. You can take this, you can take this 2, or you can take this 2. Now let's count how many sub-arrays have minimum element equal to 5. We are not doing the math. I am simply saying the count of those permutation is 2. Now, how many permutations, how many subarrays of this set have minimum element as 6? This would be only this one. How many subarrays of this permutation have minimum element equal to 1? That count is actually 12 here. How many subarrays have minimum element equal to 4? That would be 2. How many subarrays have minimum element equal to 3? That would be 2 or something like that. So essentially, we have a permutation. For each element, we will count how many times a minimum element exists. And we keep that count over here. Now, in the problem statement, we are not given P, but we are given A, and we have to count the number of possible P's over here. So we don't have this P with us, but rather we have this array with us. So like, I'm not sure if you are saying standard monotonic stack for problem F or E. Might be you can say the optimization I had from C to F was stack, but definitely not for. So now we have this array with us. How can we find the number of permutations over here of type P? Any ideas, anyone, before we jump onto the solution? Let's say this is where we are. Like, I will give you one simple problem. Can you find where 1 exists in the permutation? Like, I am saying 1 would be at unique place. Like, how will you find where does 1 exist in the permutation? Okay. The claim that 1 would exist at the place where we have maximum sounds a bit true. Like, this would be the place where we would have 1. A min can be the place where you have maximum, but for example, you have 1 maximum here and here. Any of this can be 6 or 5, something. Like, I also had this claim that wherever A is maximum, that would be the place of 1. That's not correct. But for the sake of simplicity, let's assume this for now. Like the assumption that the place where we have maximum element in the A would be the 1. gave me quite a good number of WS. So this assumption is not true, but for now, let's assume this assumption is correct. Like maximum AI is not necessary one, but I am saying for the next 5 minutes, let's assume that wherever we have maximum AI, that is the position of one. So now we have found where one exists. Now the idea is like we can treat this part independently and this part independently. Now these are two independent problems to solve for. If we put one here, everything else is more on the side. We have 5 remaining numbers. We do phi C2 to choose two numbers for this side and three numbers for this side. Let's say we give 2, 4 on this side. And here we have 3, 5, 6. So what I'm saying is I have fixed my position of 1 here. I have 2 and 4 on this side. 3, 5, 6 on this side. Now I can again treat this to be a problem for permutation of length 3. With the smallest number, like let's say our permutation becomes 3 to 1. Like the smallest number would be 3, second smallest number would be 5, third smallest number would be 6. And solve it as a permutation of lambda 2. So rather than saying 1, another way to look at it is like the place where the smallest number exists. So you can recursively solve for this part, recursively solve for this part, and we are done. So this is the idea, first idea on this, assuming that the maximum element is the position of 1. Let's say there is some black magic for now. Let's skip it. If I did not found the position of 1, then the answer is 0. Otherwise, left length, my array is like this. I'm solving it for the half, which is some element between L to R. Initially, it would be 0, 1, and then I will find the position of 1. This would be the number of ways to choose the elements, and I will recursively solve for left. Let's say, and this would work, right? Okay, I know where 1 exists. I put 1 there. I choose the number for left side. I choose the number for right side. I recursively solve for the left half. I recursively solve for the right half. And each of them, instead of 1, another way to put it is like this would be the place where the smallest element in the permutation exists. And the claim that this one would be at the maximum was my initial claim. If you do this, then you can possibly use a range max segment tree. So I initially used a range max segment tree, try to solve it this way. Find the maximum place in the array, assume that to be 1, and if equations don't satisfy, mark answer as 0, run recursively. That was. Now another way to find 1 is a different place. Maximum is not necessarily true. I will give you a counter example. Let's say my array is like this. Number of this is my permutation key. Number of times 1 exists is 6 times. Any subarray that starts from here would be the position of 1. But number of places where 2 is maximum, 3 on this side, 3 on this side, 9. So maximum A does not necessarily mean that is the minimum element. Like this is a counter test case. Like for 2 the value is 9, for 1 the value is 6, and maximum would give us 9, but 1 exists here. Another way to put it is like 1 will exist. Let's say we have 1 here. We have R elements on this side. We have L elements on this side. And this is index I, for example. Then AI would be equal to L plus 1 into R plus 1. That is another way to state. Like wherever we have 1, look at how many numbers from the left of 1 exist, how many numbers from the right of 1 exist. Product of that would be the one position of 1. And this holds even for this element as well. There are 5 elements on this side plus include this. There are 0 elements on this side, include 1. It gives you 6. That is not for true for 2. You have 2 elements here. So multiplying factor of 3 on this side. You have 3 elements here, multiplying factor of 4. This side doesn't work. If our permutation was 6, 5, 2, 6, 5, 1, 3, 4, 2, then this element would have been 3 into 4, which is equal to 12. So the correct way to find 1 is look at all the segments where this element passes through. If that count is equal to the number of segments where this is the minimum, then that is where we are. Because 1 is the minimum of all the segments. So you need to count number of segments that pass through particular index. Pi is 1 if and only if AI is equal to number of subarrays that pass through 1. So like if I have an index, I count all the elements, all the subarrays that contain that element. If my current element is minimum in all of those segments, then only my current value is 1. Now we can extend this check from L to R as well. If I am focused on L to R, element I is the minimum element only if count of these elements would be L minus I. Count of these elements would be R minus I. You take product of these and you will find minimum. So I have written a function. Check 1. I have an index I. AI is equal to number of elements from left side, number of elements from right side. If that is equal to 1, then only this precise value is 1. Now, rather than finding 1, what I can do is j equal to L, j less than equal to R, j plus plus. If check 1, if this element is 1, then I say 1 IDX is here and break here. So a pretty blunt brute force where I have left and right endpoint. I just run from one endpoint to find the position of 1, and this is my check to find 1. And the same algorithm remains. This is also order n square actually, but this is where we are. One more brute way to do is this, like rather than going from one end, let's go from both the end, which is L plus J, R minus J. If left endpoint is 1, you have found it, break it. If check right endpoint, if right endpoint is also 1, break. One more 2 pointer. Your left and right endpoint, you were initially going from left side, try to find 1. I'm saying instead of doing this, try to find, you start from left side also, you start from right side also. Keep going one at a time. Whenever you find 1, you stop there. If you didn't find 1, answer is 0. One I have using answer more is like whenever I have found invalid, I will just return it. If I did not found 1, I will mark invalid as true. And the algorithm is still same. Your left and right endpoint, you found 1. You decided to move how many elements on left side, how many elements on right side. Recursively solve for the same one. And the magic here is this should work. Let's see. And we are done. The crux here is like running these 2 pointers again. If you just move from one side, this problem is n square. You will get a theorem. Like just going through left is n square, just going through right is n square, just going through both of them is n log n. I commented out one part, only left side, this is TLE. Let's go only from the right side. This is again a TLE. But if I go through both of them, it's an AC. So this actually solves the problem. The only remaining crux is to solve this mystery why going through both of them is n log n and going through only one of them is n square. And that is something I will try to solve. But any questions, anyone so far? Give me a hands up or something if you are with me so far. And then I will just solve this mystery how this n square become n log n, and then we would be done for this time. So let's just prove this part. Okay. Number of times this for loop runs is n log n. Like that's the most bottleneck over here. And you have also seen something fancy. If I remove this and check, this becomes n square. If I remove this and check, this becomes n square. But if I keep both, it somehow becomes n square. So let's focus on this. Huh. So we have this n length array. By going through both of this side, like let's say if one is here, then this is kth element from here or something like this. Like let's say k from here, l from here. This is the distance from both of them. What I have is minimum of k comma l is less than equal to n by 2. Does this sound fair? See, like if I look at the complete array, one must be in one of the either left half or the right half. If it's in the left half, then starting from one, I will find one with at max half of the most. Or if one is in the right half, then my right pointer will find it in the less than half of the most. The idea is if one is in left half, then k is less than equal to n by 2. One is in right half, then L is less than equal to n by 2. And since I am exiting the moment I have found from the left half, right half, so like here in this case, like the number of checks I will do is 2k. In this case, the number of checks I will do is 2n. So I found one in at max n checks. This is still same, nothing crazy, but my recursion looks like this. Time complexity of solving in order n is like this. Time complexity of once I find n, I will solve for left part, and my right height would be L. My new left height would be K. Two sub problems, one for left half, one for right half, and some order n checks to move into these problems. This looks like the correct comparison for the time complexity calculations, right? And we have a check that L plus K is less than equal to n minus 1. L is greater than equal to 0, K is greater than equal to 0. This is the correct time complexity, right? I'm not sure if there are some formulas you can remember from your algorithm courses or not, but this is n log n. This recursion is n log n, but I will try to show you one another way to prove it. Let's just say we somehow knew that one is in the left side. Magically move. One is in left. Let's say someone came us and they somehow announced it. Then what am I doing over here? I had this array of length n. I checked, started checking from here. I checked L elements and I found one. Right? Like let's forget about that one. Then my time complexity becomes, this is where we are. Then for this part, let's just forget about this. It would be some t of something n by 2 less than equal to. And we didn't really do anything for this. So we keep continuing from here. Like this is again the same problem. This part is simply untouched. So what I am saying is whenever I am checking some index, the segment that index was part of, the length is becoming half. If I inspected this element, then now like this element will get into a segment where the length is half. So when I run this for loop, initially this height was in. The moment I ran a for loop on it, the size of this segment became less than equal to n by 2. Because I am saying you somehow magically find out which side of the half the element is. Now let's say you are solving this for this problem. You again somehow magically know this time one is in the right half. So if you iterate on all of these index, the moment you find one, you will stop it. So now the number of times you checked all the elements, now that segment become less than equal to n by 4. So how many times we will visit each element? Magically, no. Which half one is? And only check that half. Half. Then each element will be checked only log terms. Does this sound fair? If you magically know which half an element is, then the moment you inspected it, the segment that element was part of, the size decreased by half. Next time when you checked it, again that size became half. Next time when you checked it, again become half. So the number of comparison you will do is n log n. Does this sound right? If you magically know which half one is, then total number of checks you are doing is n log n. Now I will put it this way. Like let's say even though you know that your element is magically on right side, for the sake of it, you also check one extra elements with each check on the left side as well. We know one is on left side. And let's say we did 5 checks to find it. And for the sake of it, let's also do 5 checks on right side. Do 5 checks on right side. Like, initially we confirm that if we magically know which side one is, then the number of comparisons we will do is NlogN. Now I'm saying let's do the same thing, but whenever we are comparing left side, we will also compare one element for the sake of it on right side as well. So if we ended up comparing 5 elements on left side, we will compare 5 random elements on right side. Then what would be the number of checks now? Like what I'm saying is the moment you checked one element, you also checked one random element somewhere else. Then this time I'm claiming like the number of checks I will do is 2 NlogN. Does this sound right? Okay. I still know which magically which side one is. But if I am checking on left side, for the sake of it, I will also check on right side just because I want to do it. And even if I know one is on right side, I will also check some comparisons on left side as well, just because I want to do it. Then whenever my algorithm remains same, whenever whatever iteration I am doing, I do one extra redundant check on the other side. So if initially I was doing log n checks, for each element on average, this time I would be doing two log n checks. And overall number of checks is 2 log n. And this is actually the proof of it. Okay, because I don't know which half my one is, so I checked from both the sides. Whichever I found it, I can just go back and say, like, okay, now I knew left side the element was. If I did 5 checks on the left side, I just for the sake of it, I did 5 more checks on the right side. Or once I have found one, I can say, oh, I knew like I just needed 6 checks on the right side, but just for the sake of it, I also did 6 checks on the left side. That does not increases the time complexity of number of checks, but just because now you are doing checks from the both the sides, you are done with it. You don't have to guess which side one is. And this is one proof of why this is NlogN. So this completes problem E as well. And this is where we are. Like it's around 3 hours, 10 minutes so far. So all those people who are here, all those who are still with me, thanks a lot for tuning in for 3 hours. And this is where we are. Like if you have any questions, you can let me know. I will spend 5 more minutes and then I will just end this stream. So this is actually by one of my longest stream, but yeah. Yeah. See, so any questions, anyone? If not, then we are done. Actually, I can give you one more homework problem that you can solve for if you want how to solve it. This problem number of subpermutations from education round 66 is actually the exact same solution we had discussed today. Like few things gets more involved over here, but the core idea of how to make n square solution and log n appears here as well. So you can try it as well. Or actually, I will have to check once if this is the right problem or not. No, this isn't actually. You can ignore it. You can solve it if you want, but today's idea is not related to this problem. So I remember wrong, but yeah, that's what. Yeah. So thanks everyone. If you are still here, don't forget to like, share, and subscribe. And thanks a lot for joining in today. So I intend to wrap up this stream in next couple of minutes. If you have any random questions for me, you can say ask them. I will try to answer for a couple of more minutes and then we are done. So thanks everyone for joining in today. And thanks everyone. Like current state of cheating on Codeforces. Frankly, I don't have much to say. All I can hope for is like rating would become less meaningless due to this. And then we will, which in turn will lead to less cheaters then. That's what I can say mostly. I am around 26 years old now. Yeah, like problem rating. Yeah, like problem rating is decreasing. That's the side effect. But that's where like do we have editorials published? Like my advices are actually you can find it on the Discord server. Yeah, like virtual contest would be the way to go. And you can join in my Discord server and look at roadmap to ride channel. And here I have all the advices for you. Like 1200 to 1700. You can look at roadmap to ride channel on my Discord server. You can join this Discord and look at this channel. Like here I have put in all the advices I have to give it for you. So thanks everyone for joining in today. Thanks a lot.